Welcome to a quiet corner of your evening. You've found your way to the Dreamy Doctor, a place where science flows like a stream under starlight, and questions drift into answers slowly, gently. Tonight, we begin a long and restful journey into the world of sleep, its rhythms, its mysteries, and the subtle symphony it plays behind closed eyes. Let this be your invitation to slow down, to breathe a little deeper, to listen, not with urgency, but with ease. If you'd like more calm explorations like this, you're gently welcome to like this video. And if it feels right, subscribe, so you'll always have a soft place to return to when the world gets a little loud. Now, settle in, and let's begin. Sleep, at first glance, seems like silence, a nightly vanishing act, a turning down of the lights within. But beneath the hush, beneath the blanket and the breath, sleep speaks a fluent language of restoration, coded in chemistry, structured in cycles, shaped by evolution's patient hand. To sleep is not to be idle. It is to move inward, to retreat into a theater where the body repairs, where the mind rewrites, and where consciousness lets go, just a little. In sleep, we are not unconscious, but differently aware, our awareness turned inward, watching without eyes, feeling without movement. Sleep is not escape. It is return, a daily homecoming to a softer version of self. When we surrender to it, we do not disappear. We dissolve into waves, into pulses, into the slow music of biology. Across cultures and across centuries, sleep has always been sacred. It is the hour of dreams and myths, of messages from the unconscious, of spirits and stories. But beyond the poetry lies the physiology, and the science tells us this. Sleep is not optional. It is as necessary as food, as breath, as heartbeat. When we sleep, our brains do not shut off. They tune to a different frequency, a quieter one, a deeper one designed not for action, but for integration. This is the language of stillness, a gentle vocabulary made not of words, but of waves, electrical rhythms, chemical messengers, and silent intentions. Tonight, we will learn to listen. You are not alone in your slumber. The world sleeps with you, from the largest whales, floating in slow circles beneath the sea, to the tiniest flies, resting in the pause between wing beats. Sleep is a shared inheritance, a biological ritual, ancient and wise. Every living creature that possesses a brain, from insects to mammals, has evolved a version of sleep. Not all sleep the same way. Some nap in quick bursts. Others fall into deep, hours-long rest. But the pattern remains. The body yielding. The senses softening. The mind slipping below. Dolphins, those brilliant swimmers, let half their brains sleep at a time. One hemisphere resting, while the other remains alert to the ocean's call. Birds in migration glide with their eyes half shut, catching moments of sleep in midair, threading dreams between miles. Even plants, in their own rhythm, follow circadian patterns, leaves drooping at night, petals closing against the moonlight, as though they too know that every life needs rest. The sun sets not just for you, but for the forest, for the field, for every beating thing. In this shared stillness, we are connected through instinct, through design, through the soft promise of sleep. When night arrives, the earth exhales, The tempo of life slows. Even time seems to loosen its grip. It is humbling to remember that in the act of sleep, we join a planetary rhythm, a pulse that predates us and continues without us and welcomes us nightly. Sleep is not just personal, it is universal. Deep within your body, nestled in the brain's gentle core, is a master clock, a rhythm maker, a quiet conductor of the body's orchestra. It is called the suprachiasmatic nucleus, a tiny cluster of neurons in the hypothalamus, just above where your optic nerves cross. Though only the size of a grain of rice, this clock regulates nearly every rhythm within you. Your sleep, your hormones, your temperature, your hunger, your alertness. This is your circadian rhythm, a 24-hour cycle, guided by light, synchronized to the rise and fall of the sun. Each morning, as sunlight touches your skin and filters through your eyes, this inner clock resets itself. It sends signals to wake you gently, raising your cortisol, lowering your melatonin, nudging your body toward wakefulness. And in the evening, as light fades, the clock begins its descent. Core body temperature drops. Melatonin levels rise. The mind starts to fog at the edges, readying itself for surrender. This rhythm doesn't rely on your choices. It hums beneath your habits. You cannot override it, though many try, with screens at midnight, with coffee in the dark. But the clock is patient. It waits and gently corrects when it can. There are rhythms within rhythms. Cells in the liver, in the heart, even in the skin, each with their own internal timekeepers, each dancing in harmony with the central pulse. When circadian rhythms fall out of step, as they do in jet lag, in shift work, or sleepless nights, the body becomes confused. It forgets when to rest, when to digest, when to heal. And so we feel it as fog, as fatigue, as that quiet ache beneath the eyes. But when rhythm is restored, when your day begins with sunlight and ends with quiet, the body sighs in relief. It remembers what it was built for. To sleep with the rhythm of the earth is to be whole again as day fades and shadows begin to stretch across the walls. A quiet messenger stirs in the center of your brain, the pineal gland, no larger than a grain of rice. This gland sits between the two hemispheres of the brain, just behind and above the brainstem, a sentinel of darkness, waiting for the light to fall away. When your eyes detect the end of day, when blue light retreats from the retina, signals travel through the optic nerve into the suprachiasmatic nucleus, and finally to the pineal gland. Here, in this quiet cave of tissue, melatonin begins to bloom. Melatonin, the hormone of dusk, the keeper of the night, is synthesized from serotonin and released into the bloodstream as darkness deepens. It flows gently through your body, whispering to your cells that it's time to rest. Melatonin does not force sleep. It invites it. It lowers core body temperature, modulates blood pressure, and slows metabolic activity. It primes the brain to shift from beta waves of alertness to the slower alpha and theta rhythms of calm. Its release is deeply tied to light, especially blue light, the wavelength emitted by the rising sun and by our glowing screens. This is why light before bed, especially from phones and tablets, can suppress melatonin's delicate signal, confusing the body into believing it's still daytime. even when the sky has long gone dark. In the absence of melatonin, the edges of sleep become harder to reach. We turn, we wait, we drift away too slowly. But when the pineal gland is allowed to work, when the lights are dim and the world is still, melatonin flows like a tide within the veins, preparing every system for the quiet night ahead. It is moonlight made molecular, all throughout your waking day. As you walk, think, move, and focus, your brain is quietly collecting a chemical, adenosine. It builds up hour by hour, like soft sand filling a jar. And as its levels rise, so too does your need for sleep. Adenosine is a byproduct of cellular activity, especially the use of ADP, your cell's main energy currency. The more energy you use, the more adenosine collects. It binds to specific receptors in the brain, particularly in regions like the basal forebrain, sending a simple, steady message. You're getting tired. This process is part of what scientists call sleep homeostasis, a balancing act where the longer you stay awake, the greater your pressure to sleep. Unlike circadian rhythm, which follows time, sleep pressure follows usage. How long your neurons have been firing, how much you've thought, moved, engaged. As adenosine builds, it dulls cortical activity, reducing alertness and cognitive precision. You may feel it as heaviness behind the eyes, a fog at the edges of your mind, a gentle pull downward. And then, as you finally rest your head, adenosine levels begin to fall, washed away during deep sleep, especially in the slow wave phase, by the glymphatic system, a cleansing flow of cerebrospinal fluid that clears the mind's metabolic debris. But there's a twist. Caffeine, this common stimulant, doesn't stop adenosine from forming. Instead, it blocks its receptors. It masks the signal. The sand still gathers in the jar, but you no longer hear it falling. That's why when the caffeine wears off, you may crash. The adenosine that had been waiting returns all at once. Adenosine is not your enemy. It is your compass. It tells you when you've done enough for one day, when it's time to stop input and allow processing to begin. In this way, sleep pressure and circadian rhythm work as partners. One measuring time, the other measuring effort, both guiding you gently to sleep. Biology thrives on balance, not in perfection, but in continuous correction. This balancing act, called homeostasis, is the foundation of life. Just as the body balances blood sugar, temperature, and hydration, so too does it balance rest and activity. Sleep, in this equation, is not a luxury, but a counterweight, the other side of wakefulness. When you miss sleep, your body notices, and the next night, you'll enter slow-wave sleep more quickly. You'll spend more time in it, more deeply immersed. This is rebound sleep, a form of internal compensation, the body's way of repaying a biological debt. Homeostatic sleep regulation doesn't rely on your permission. Even when you resist it, it will find a way. Your reaction times will slow. Your memory will blur. Your mood will dip. Eventually, you will succumb because sleep is not optional. It is survival. Sleep homeostasis is also finely tuned to sleep quality, not just quantity. It matters how you sleep. If your night is fragmented, light disturbed, breath interrupted, dreams broken, your body may not feel rested. Even after many hours, the balance will still be off. the mind's still hungry. That's why deep, consolidated sleep, especially in the early hours of the night, is so vital. It's when the brain restores its neurochemical balance, recharges its networks, and adjusts emotional circuits. In a healthy rhythm, sleep becomes self-sustaining, each night feeding the next, each dream settling the day behind it. To support this cycle, we create routines, a consistent bedtime, a quiet hour, a dim room. These simple rituals tell the body it is safe to let go, to trust the process, to fall into balance. And so homeostasis guides us, a gentle pendulum between effort and ease, between consciousness and quiet. At the edge of dreams, balance becomes the doorway. As twilight deepens, the body begins its silent descent into night. Even before the eyelids flutter, before thoughts begin to soften, a physiological transformation is already underway. One of the most crucial changes is this. Your core body temperature begins to fall, not dramatically, just a gentle drop, about 1 degree Celsius, or 2 degrees Fahrenheit. But this modest shift sends a powerful message that it's time to rest. The circadian rhythm, guided by the brain's internal clock, instructs the body to release heat from the core. Blood vessels near the skin dilate, allowing warmth to flow outward. You may feel your hands and feet warm up. Paradoxically, as your inner self cools, this cooling is not merely symbolic. It is functional. The drop in core temperature is necessary to initiate and maintain sleep, particularly slow-wave sleep, when the brain consolidates memories and the body repairs itself from the day's wear. Sleep becomes more elusive when this cooling process is disrupted. A room too warm or exercise too close to bedtime can delay sleep onset. The body needs a signal, a change in temperature, a metaphorical sunset within. This is why people sleep more soundly in cooler environments, around 60 to 67 degrees Fahrenheit, or 15 to 19 degrees Celsius. Seems to be the optimal range. Not too cold to constrict the skin, not too warm to interfere with thermoregulation. And then there's light, perhaps the most potent synchronizer of all. Light doesn't just illuminate the world. It instructs the brain through specialized photoreceptors in the eye. The presence or absence of light adjusts the clock inside the suprachiasmatic nucleus, regulating melatonin, shaping hormone release, and shifting the circadian rhythm forward or back. Artificial light, especially from LEDs and screens, can trick the body into thinking it's still daytime. This delays melatonin production, warps sleep timing, and dulls the restorative phases of sleep. By contrast, dim light, warm light, and darkness itself tell the brain that night has truly come. And so, as you prepare for rest, remember this: cool your body, dim your space, and let light, or the absence of it, guide you gently to sleep. When you drift into sleep, you do not simply shut off. You enter a dance, an alternating rhythm, a symmetry of states, each with its own tempo, its own purpose. There are two main stages of sleep: NREM, non-rapid eye movement, NREM, rapid eye movement. They do not compete. They collaborate, together composing the full symphony of sleep. NREM sleep arrives first, quietly, like fog rolling over the land. includes 3 substages. Stage 1, the light doze. Stage 2, where sleep begins to stabilize. And Stage 3, the deepest rest, known as slow-wave sleep. In NREM sleep, brain waves slow dramatically. Neurons fire in synchrony, producing delta waves. Broad, unhurried, like waves across a quiet lake. It is here that the body rebuilds. Tissue is repaired. Immune activity strengthens. Growth hormone is released. The heart slows, breathing deepens, and consciousness recedes. Then, after about 90 minutes, a new phase emerges. REM sleep, where the eyes dart beneath closed lids, and dreams begin to unfold. In REM, the brain becomes active again, sometimes more active than during wakefulness. The cortex lights up, especially areas involved in memory, emotion, and creativity. Yet curiously, the body becomes still. REM atonia, a temporary paralysis of skeletal muscles, prevents us from physically acting out our dreams. Only the diaphragm continues, keeping breath flowing as the brain spins its stories. Throughout the night, you cycle between NREM and REM every 90 minutes or so, but the balance shifts. Early in the night, NREM dominates, deep, healing sleep. As dawn approaches, REM takes over, longer, richer, more vivid. Each phase serves a purpose, each one essential. Without NREM, the body suffers. Without REM, the mind frays. Together, they form a balanced duet. 2 sides of the same night, 2 languages of restoration. Sleep does not begin with a sudden switch. It begins with a slow fade, a letting go, a floating. This is stage 1 sleep, the lightest phase, a doorway more than a destination. You are neither fully awake nor truly asleep. Here, brain activity begins to slow. Alpha waves, present in relaxed wakefulness, give way to slower theta waves. These signals oscillate between 4 and 7 hertz, gentle and irregular. As consciousness loosens its grip, the eyes may roll slowly beneath the lids. Muscles relax, and yet you may still hear the world around you. A passing car, a creaking floor, the distant bark of a dog. But these sounds no longer pull you upward. They float by, unimportant, unattended. Many people experience hypnic jerks in stage 1, sudden, involuntary muscle twitches, often accompanied by a sensation of falling. It is the brain's last attempt to hold on, to question whether it is safe to release. Once reassured, it lets go. Stage 1 usually lasts just a few minutes, a narrow bridge into deeper sleep. If you're awakened during this time, you may not even realize you had fallen asleep at all. But though it is fleeting, stage 1 is precious. It marks the beginning of the descent, a first step into the underwater world. From here, you move forward, not abruptly, but gently, as you drift past the delicate veil of stage 1. You arrive in stage 2 sleep, the first true anchor of rest. Here, the world grows dimmer, the body more still, and the mind begins to change its rhythm. Stage 2 is not yet deep sleep, but it is stable, structured, and protective. It comprises nearly 50% of a full night's rest, the most abundant of all the sleep stages. Within this stage, the brain begins to pulse in patterns, like lighthouses on a quiet sea. The first of these are called sleep spindles. sudden bursts of electrical activity, oscillating between 11 and 16 hertz, lasting less than 2 seconds. They flicker across the cortex like brushstrokes of static, not chaotic, but purposeful. Sleep spindles are believed to serve many functions: protecting sleep from disturbance, facilitating memory consolidation, and perhaps strengthening neural connections formed during the day. In sleep studies, individuals with more spindles often show better learning and problem-solving after sleep. Then there are the K-complexes, sharp, single waves of high amplitude, often triggered by subtle external stimuli. A shifting blanket, a distant sound, a murmur of thought. But instead of waking you, these waves shield you, a protective reflex, allowing the brain to assess the signal, then choose stillness over action. During stage 2, body temperature continues to drop. Heart rate slows, and eye movements cease. Muscle tone relaxes, but not fully. The body is quiet, yet not paralyzed. And though you are now firmly within sleep, your brain remains watchful in its own way, actively filtering, processing, and beginning the nightly work of reordering your world. This is the gatekeeper stage, a place between the light and the deep, a landing where rest gathers its strength before diving further inward. Below stage 2, the mind descends into its deepest waters. Stage 3, also known as slow-wave sleep or deep NREM sleep. Here, you're no longer aware of the room, or the day, or even yourself. The brain's activity slows to a crawl, producing delta waves, broad, powerful rhythmic currents, measuring less than 4 hertz. They rise and fall like ocean swells. They're the signature of profound rest. This stage is critical for the body, for healing, for growth, for renewal. Growth hormone peaks during this time, facilitating tissue repair, muscle restoration, and cellular regeneration. The immune system becomes highly active in slow-wave sleep. Inflammatory markers fall, and white blood cells patrol with focus. It is during this stage that the body fights infection, repairs injury, and restores itself after daily wear. But the brain, too, is at work, not in conversation, but in maintenance. The glymphatic system, a network of channels that clears metabolic waste, becomes highly active during slow-wave sleep. Toxins such as beta amyloid, which accumulate in conditions like Alzheimer's, are flushed away as if the brain were rinsed. In gentle, pulsing tides, memory consolidation also takes place here, particularly of declarative memory. Facts, names, knowledge. The hippocampus replays patterns of activation from the day, sending them to the neocortex for long-term storage. Muscles remain relaxed, but not fully immobilized. This is not the dream world of REM. This is the deep chamber of physical rest. If someone were to wake you now, you would feel disoriented, slow to respond, as though you had been pulled from a distant cave. The elderly tend to get less slow-wave sleep. Children, much more. Its decline is a natural part of aging. Though certain practices, such as exercise, cool environments, and sleep consistency, can help preserve it. This stage is sacred, non negociable. It is the quiet core of sleep, the dark water beneath the stars. And without it, the body frays. After slow-wave sleep, the brain begins to stir, not toward waking, but into REM sleep, rapid eye movement, the final stage of the cycle, the most mysterious, and perhaps the most magical. During REM, your eyes move rapidly beneath closed lids, tracking scenes that unfold in your dreams. The cortex lights up again, especially regions involved in emotion, memory, and vision. It is as if the brain is rehearsing life, without the burden of reality. Despite the intense neural activity, your muscles are paralyzed, a mechanism called REM atonia, designed to prevent the physical acting out of dreams. Only your eyes and diaphragm remain free. Everything else is still. It is during REM that dreams become vivid, emotional, often surreal. Scenarios shift without logic. Characters morph. Time bends. And yet, the brain takes it all seriously, processing emotional memories, evaluating social situations, making creative connections that waking logic might miss. REM is thought to enhance procedural memory, skills, habits, sequences. It is the stage where musicians refine melodies, where athletes encode muscle memory, where artists combine distant ideas into new forms. Unlike slow-wave sleep, which is more prominent in the early night, REM sleep dominates the later cycles, lengthening as morning nears. In a full 8-hour night, you may experience 4 to 6 REM episodes, each one longer than the last. Disruption of REM, from stress, substance use, or fragmented sleep, can lead to irritability, poor concentration, and reduced emotional resilience. But when REM flows freely, dreams become a laboratory for the self, a place to rehearse, to integrate, to imagine. Some describe it as the brain dreaming itself awake. It is the brightest part of the night, a flicker of insight, a playground of the mind, a rehearsal of tomorrow, all while the body lies still. At night, while the world outside grows still, your body enters its own quiet choreography, a delicate dance of repair, regulation, and renewal. You may feel still. You may seem still. But beneath the surface, every cell, every system is deeply engaged. Your digestive system slows, not stopping entirely, but easing its pace. Energy is conserved. Focus is shifted inward. The liver metabolizes hormones and toxins. The kidneys filter the day's remnants with gentler rhythms. The immune system, unburdened by the distractions of daytime vigilance, becomes more methodical. White blood cells increase their patrol. Inflammatory responses become calibrated. Antibodies are formed, all preparing you to face the world again at dawn. In the endocrine system, a slow tide of chemical messengers rises and falls. Growth hormone, critical for tissue repair and cellular growth, peaks during slow-wave sleep. It nourishes bone, muscle, and skin, healing the micro-tears, the unnoticed wounds, the hidden wear of being alive. Meanwhile, levels of cortisol, your body's primary stress hormone, dip during the early night, allowing calm to settle across your system, then slowly begin to rise toward morning, gently nudging the body back toward alertness. Even your skin, that quiet outer shell, regenerates more efficiently in sleep. Collagen production increases. DNA damage from sunlight and pollution is repaired. Though sleep may look like stillness, it is anything but passive. It is an inward journey, not of movement, but of maintenance, a biological ritual that resets your strength, your immunity, your resilience. Sleep is not one long descent into darkness. It is a rhythmic dance, a cycle, a loop, a spiral that turns quietly through the night. From the moment you close your eyes, your brain begins a journey, not downward, but inward, through stages of depth and renewal. This journey follows a gentle architecture known as the sleep cycle. The cycle begins with stage 1, a light drift, where awareness slips like silk from skin. Muscles relax, heart rate slows, and brainwaves shift from beta to alpha and into soft, pulsing theta. Then comes stage 2, a slightly deeper rest. Here, your brain produces sleep spindles, quick bursts of activity, NK complexes, sudden waves that may protect sleep from being disturbed. You are less aware of your surroundings. You've entered the rhythm. Next is stage 3, also known as slow wave sleep or deep sleep. This is the territory of delta waves, long, slow oscillations that signal the body's deepest rest. Muscle repair occurs here. Growth hormone is released, and the immune system rebuilds. Then, the cycle reverses. Your brain rises slowly, back through lighter stages, and into a state that feels paradoxical. REM sleep. Here the body lies still, muscles almost paralyzed, but the mind becomes bright again. Eyes dart beneath closed lids. Breathing quickens, and dreams bloom. One full cycle takes about 90 to 110 minutes. And each night, you repeat this loop 4 to 6 times, each with slight variation. Like tides, the cycles rise and fall, light to deep, deep to dream. The beauty of sleep lies not just in depth, but in pattern, a graceful repetition that supports life with every turn. Your first sleep cycle is rich in deep, slow wave sleep. It comes early, just an hour after you drift off, and carries the weight of restoration. Here, the body works most quietly, clearing cellular debris, repairing tissue, resetting the nervous system. But as the night moves on, deep sleep grows lighter, and REM sleep begins to expand. Longer, more vivid, more emotionally rich. By the third or fourth cycle, your night becomes a theater of dreams. REM stages may stretch to 45 minutes, weaving emotion, memory, and story into surreal sequences. These alternating stages, non-REM, then REM, for what scientists call ultradian rhythms. Unlike the 24-hour circadian rhythm, ultradian cycles repeat several times nightly, carrying the mind through internal weather. And the pattern matters. If sleep is fragmented, the full rhythm is disrupted. You may miss deep sleep or awaken before REM begins. The result? You wake unrestored, not because you slept less, but because the architecture was broken. Sleep is more than time spent in bed. It is time spent in balance, rising and falling, over and over, like breathing. Part 16, Circadian Rhythms, time written in the blood. Sleep is not only governed by the brain, but by time itself, an inner time kept without clocks, guided by light and shadow. This is your circadian rhythm, a roughly 24-hour cycle that shapes sleep, alertness, temperature, hormone release, and even mood. At the center of this rhythm lies a small bundle of neurons in the brain's hypothalamus, called the suprachiasmatic nucleus, or SCN. It sits just above the optic chiasm, where the eyes meet, ready to receive light. Each morning, as sunlight enters your eyes, it sends signals to the SCN. A message. It is day. From his cue, the body coordinates everything. Melatonin, the hormone of darkness, is suppressed. Cortisol rises gently. Body temperature warms. The digestive system stirs. As day progresses, alertness peaks, then slowly tapers. By evening, melatonin returns, soft and subtle, inviting sleep. If you follow this rhythm, with regular wake and sleep times, with exposure to natural light, with calm in the evening, your sleep becomes smoother, more efficient, more restful. But if the rhythm is disrupted by shift work, jet lag, late night screens, your sleep may grow shallow, disordered, mismatched with your biology. Circadian rhythm is not rigid. It shifts gently with age, earlier in childhood, later in adolescence, then slightly earlier again with age. But always, it follows the sun, the moon, and the quiet instructions written deep in your cells. At night, while the world outside grows still, your body enters its own quiet choreography, a delicate dance of repair, regulation, and renewal. You may feel still, you may seem still, but beneath the surface, every cell, every system is deeply engaged. Your digestive system slows, not stopping entirely, but easing its pace. Energy is conserved. Focus is shifted inward. The liver metabolizes hormones and toxins. The kidneys filter the day's remnants. With gentler rhythms, the immune system, unburdened by the distractions of daytime vigilance, becomes more methodical. White blood cells increase their patrol. Inflammatory responses become calibrated. Antibodies are formed, all preparing you to face the world again at dawn. In the endocrine system, a slow tide of chemical messengers rises and falls. Growth hormone, critical for tissue repair and cellular growth, peaks during slow-wave sleep. It nourishes bone, muscle, and skin, healing the micro-tears, the unnoticed wounds, the hidden wear of being alive. Meanwhile, levels of cortisol, your body's primary stress hormone, dip during the early night, allowing calm to settle across your system, then slowly begin to rise toward morning, gently nudging the body back toward alertness. Even your skin, that quiet outer shell, regenerates more efficiently in sleep. Collagen production increases. DNA damage from sunlight and pollution is repaired. Though sleep may look like stillness, it is anything but passive. It is an inward journey, not of movement, but of maintenance, a biological ritual that resets your strength, your immunity, your resilience. As you move through the layers of sleep, your heartbeat slows. Each pulse stretches just a little longer. Each beat whispers instead of thudding. The heart, which works tirelessly during the day, is granted a reprieve, a chance to move in smooth, measured rhythms. In non-REM sleep, especially in the deeper stages, your heart rate can drop by 20 to 30%. This gentle slowing is regulated by the parasympathetic nervous system, the rest and digest mode of your body's neural design. Blood pressure falls, vascular tension eases, The cardiovascular system is allowed to recover. The breath, too, begins to shift from the quick, shallow rise and fall of daytime to a deep, even flow. The respiratory rate decreases. Each inhale is slower, each exhale softer. The chest rises like a tide, falls like a leaf, steady, rhythmic, unforced. Carbon dioxide is expelled with less urgency. Oxygen is delivered where it's needed, not in response to motion, but to metabolism. Then, in REM sleep, the pattern changes. The heartbeat becomes variable again, faster at times, slower at others, reflecting the intensity of dreams, the activation of emotion, the brain rehearsing waking life in disguise. Breathing becomes shallower, more irregular, as if it is echoing the dreamscape, pausing in fear, racing with joy, matching the imagined drama unfolding behind the eyes. Yet even here, the body knows what it's doing. The autonomic nervous system modulates these shifts, subtle, silent, seamless. As you sleep, your breath and heart conduct a symphony of survival, one that plays every night, without applause, without awareness, and always without pause, with the mind dreaming in colors and symbols, and the heart fluttering in sync. There remains one more transformation, the stillness of the muscles. During most of sleep, the body rests in stages. Muscle tone decreases, tension fades, the posture softens, but in REM sleep, something more profound occurs. Muscle paralysis. This is not a flaw, but a safeguard, a protective mechanism called REM autonia. As the brain enters its vivid dream cycles, it sends signals down the spinal cord to inhibit motor neurons, the nerve cells responsible for movement. The result, your limbs go quiet, your arms and legs lie still, even as, in your dreams, you may be running, flying, fighting, or falling. Only a few critical muscles are spared, those needed for breathing and for moving the eyes. Everything else surrenders to stillness. This temporary paralysis prevents injury. You do not leap from the bed during a dream. You do not act out your visions. In healthy sleep, this process unfolds seamlessly. You drift, you dream, you lie at peace. But in certain rare disorders, such as REM sleep behavior disorder, this inhibition fails. The muscles move, the dream becomes physical, and the body begins to act out the mind story. Such conditions offer a window into the delicate balance of REM control. Then there's sleep paralysis, a phenomenon where REM autonia briefly lingers into wakefulness. You awaken before the paralysis has lifted, and for a moment, a few seconds, sometimes minutes, you are awake but unable to move. It is disorienting, sometimes frightening, but temporary and benign. Most people will never notice the quiet disappearance of muscle tone each night. But it happens reliably, beautifully, a silent stillness, so the brain can wander freely. In REM, the mind becomes motion, the body becomes moonlight, untouched and still. As you sleep, your mind does more than dream. It cleans itself, not with soap and water, but with flow, with a system hidden deep within the folds of the brain, a system known as the glymphatic network, discovered only in recent years. The glymphatic system is a specialized channel, a cleansing river that activates, almost exclusively during sleep. Throughout the day, as neurons fire and process, as you think, move, feel, and remember, your brain produces waste, tiny metabolic byproducts like beta amyloid and tau proteins, which, if left unchecked, can accumulate and disrupt healthy function. But at night, as you enter slow-wave sleep, your brain cells shrink slightly, creating space between them, room for fluid to flow, cerebrospinal fluid, a clear liquid that bathes the brain and spinal cord, moves in rhythmic pulses through this space, carrying away debris, flushing out what no longer serves. This process is not noisy or fast. It is subtle, methodical, a molecular tide. The system works most efficiently during deep sleep, especially in the early night. Miss that window, and the cleanup may remain incomplete. This may help explain why long-term sleep deprivation is linked to cognitive decline, memory loss, and neurodegenerative diseases. The glymphatic system depends on stillness, on darkness, on the absence of wakefulness. When you rest, your brain rinses itself, gently, patiently, preparing you not just to survive tomorrow, but to remember it. Sleep is not one thing. It is many systems in harmony. Among the most delicate of these is the endocrine rhythm, a chemical symphony that pulses softly throughout the night. Each night, as sleep begins, your pituitary gland releases growth hormone, especially during slow-wave sleep. Despite its name, this hormone is not just for children. In adults, it helps repair muscle, regrow tissue, heal micro tears and injuries, and strengthen bones. This repair is timed, linked directly to your deepest rest. The more uninterrupted your sleep, the more fully the hormone can rise, the more effectively your body restores itself. Meanwhile, cortisol, your stress-regulating hormone, falls during the early part of the night. This dip creates space for calm, for healing, for emotional reset. Toward morning, cortisol rises again, slowly, naturally, preparing you to wake, to move, to think. This rhythm is ancient, tied to the arc of the sun, the predictability of time, the way dawn has always followed dark. Other hormones join in as well. Melatonin, guiding sleep onset. Leptin and ghrelin, balancing hunger signals. Insulin, adjusting sugar metabolism. In healthy sleep, these hormones form a cycle, a slow wave of balance that rises and falls. Without interruption, disrupted sleep interrupts this wave. Night shifts, blue light, and inconsistent schedules can desynchronize hormonal timing, leading to insulin resistance, weight gain, emotional imbalance. But when you honor the rhythm, when you lie down gently and let the dark do its work, the orchestra plays as it was meant to, and your body remembers what it means to feel whole. Beneath every dream, beneath every breath, there flows a current, not of water, but of electricity, measured in waves. These are your brain waves, oscillating patterns of neural activity, shifting throughout the sleep cycle, guiding the body through stages of wakefulness, slumber, and renewal. In waking life, your brain is mostly in beta waves, fast, sharp, focused, between 13 and 30 hertz. These are the waves of attention, decision-making, active thought. As you relax, Beta waves give way to alpha waves. Gentler, more synchronized, around 8 to 12 hertz. You may feel this as calm before sleep, a state of quiet awareness. Then comes the descent. In stage 1 sleep, theta waves emerge, slower rhythms, 4 to 7 hertz, associated with drowsiness, daydreaming, hypnagogic imagery. The world begins to blur. The mind turns inward in slow-wave sleep, the slowest and deepest state. Your brain enters delta waves, less than 4 hertz. Here, the neurons pulse in near unison, a slow, powerful chorus, resting the body, healing the mind. During REM sleep, the pattern changes again. Brain activity becomes mixed, closer to wakefulness. You see sawtooth waves, flickers of alpha and theta, signaling a dream state that feels real, but remains safely contained. These brainwave transitions are not random. They are carefully coordinated. The thalamus, the cortex, the brainstem, they communicate silently, adjusting frequency, tuning the mind like an instrument. You do not feel these waves, but they feel you. They carry your memories, your emotions, your healing. They tell the difference between rest and restoration. To sleep well is to surf these waves, not with effort, but with surrender. While the body rests, the mind remembers, not always through dreams, but through structure, through selection, reinforcement, and reorganization. This process is called memory consolidation, and it is one of sleep's most vital gifts. Each day, you gather information, conversations, images, names, numbers, skills, emotions. But raw experience alone is not memory. It is sleep that turns experience into something that lasts. In slow-wave sleep, the hippocampus, a seahorse-shaped structure deep in the brain, replays recent patterns of neural activity. This replay strengthens connections between brain regions, transferring important memories to the neocortex for long-term storage. This is especially true for declarative memory. Facts, knowledge, spatial information. The process is subtle, but highly selective. Some memories are amplified, others gently forgotten. Then in REM sleep, another type of memory is refined. Procedural memory. How to ride a bike, play an instrument, solve a puzzle. REM sleep also supports creative problem solving, linking distant ideas, and making connections not obvious in waking life. Studies have shown that people perform better on tests after a full night of sleep, even without additional study. The brain, left alone in the dark, perfects what it was given, but without sleep, this process falters. New information becomes foggy. Long-term storage is disrupted. Learning suffers. Sleep is not a break from memory. It is memory's masterwork. It is not about remembering everything. It is about remembering what matters. Each night, as you lie quietly, your brain sifts through the day, filing, sorting, weaving the story of who you are. The mind does not only archive facts while you sleep. It also tends to feelings. Emotions do not disappear with the sun. They stay with you, in your thoughts, in your body, in your dreams. Sleep is the mind's way of processing emotion, of softening sharpness, of resolving tension, of quietly asking, what does this mean? In REM sleep, regions of the brain tied to emotion, especially the amygdala and anterior cingulate cortex, become highly active. These structures interpret fear, sadness, joy, anger. At the same time, levels of norepinephrine, a stress-related neurotransmitter, drop dramatically. This creates a unique state, one in which emotional memories are reactivated, but without the physical stress response. In essence, the brain replays upsetting or complex emotions, but in a safer, calmer state. This is why dreams, especially vivid ones, often reflect our unresolved feelings. A conversation we wish we'd handle better. A loss we have yet to understand. A fear that lingers beneath words. Sleep allows the brain to reframe these feelings, to disconnect the emotional sting from the memory itself. Over time, this leads to emotional regulation, resilience, clarity. When you wake after such nights, you may feel lighter, not because the emotion is gone, but because it has been processed, because the brain has gently worked through it in silence. And so, sleep becomes your silent therapist, listening without words, healing without judgment. Night after night, the mind untangles itself. Not all dreams are silent movies. Some invite the dreamer to step onto the stage, to become both watcher and writer. This is the phenomenon known as lucid dreaming, a rare, curious state in which you become aware that you are dreaming while still inside the dream. It most often occurs during REM sleep, when the brain is highly active, and in certain moments, the dream self stirs, not fully awake, but conscious within its imagined world. Lucid dreamers may fly, reshape the dream, revisit places or people long gone. But not all lucidity is about control. Sometimes it is simply the recognition, I am dreaming, a whisper of awareness that gently opens the dream from within. In brain scans, lucid dreaming activates regions in the prefrontal cortex, normally quiet during sleep, areas linked to self-awareness, logic, and decision-making. Scientists have even communicated with lucid dreamers during sleep, using eye movements as signals. Left, right, a code from the dreamer to the waking world. Lucid dreams may occur naturally, or they may be cultivated through mindfulness, dream journaling, or a gentle technique called reality testing. Checking during the day if you are awake until the habit carries into the dream. These moments are not just playful. They may offer benefits, reduced nightmares, enhanced creativity, even mental rehearsal for skills and challenges. Still, not everyone will experience them, and that is okay, for even without lucidity, the dreaming mind holds wonder. But when lucidity arrives, it is like a candle lit in a vast room, a moment of clarity in the fog of sleep. Most dreams drift by gently, like autumn leaves in water, but now and then a darker current appears, a nightmare. Nightmares are not broken dreams. They are emotional rehearsals, unsettling, vivid, sometimes terrifying, but deeply human. They arise most often during REM sleep, especially in the late night, when REM stages grow longer and emotions run deeper. The amygdala, the brain's emotional sentinel, becomes highly active, scanning for threat, interpreting fear. But here, in the dream, There is no real danger, only the simulation of danger. Nightmares are shaped by stress, trauma, anxiety, or emotional overwhelm. Children may dream of monsters, adults of falling, losing control, being chased. These dreams may be frightening, but they serve a purpose. They help us confront fear in the safety of sleep, allowing the brain to explore threat, to simulate reaction, to prepare for survival. In this way, a nightmare is like a fire drill, disturbing in the moment, but useful over time. For some, nightmares become chronic, as in post-traumatic stress disorder, where trauma replays again and again, unresolved. But even here, the mind is trying to process, to protect, to make sense. Therapies such as image rehearsal therapy or gentle lucid dreaming training can help reduce nightmare frequency by giving the dreamer back a sense of control. Not all shadows are threats. Some are reflections, emotional messages that the conscious mind was too busy to hear. The nightmare, though loud, is often a whisper in disguise. When the body sleeps and the world falls away, the mind is free to wander. It drifts across landscapes it never built, combines thoughts it never paired, creates stories, images, feelings that have never existed before. This is dreaming as creativity, a function not of logic, but of association. In the dream state, especially REM, the brain relaxes its usual boundaries. It disconnects from sensory input. It silences the critic, and it begins to recombine ideas in novel, surprising ways. The default mode network, a constellation of brain regions associated with imagination, self-reflection, and creative insight, becomes active. Ideas no longer follow straight lines. They curl, twist, bloom. This is why dreams feel strange, yet often meaningful. The mind is telling stories, not bound by physics or time, but by emotion, symbol, and memory. Great thinkers have drawn from this well. The structure of benzene, the tune of yesterday, the concept of Frankenstein, all were inspired by dreams. Even when forgotten upon waking, dreams may leave behind a residue, a thought, a shift, a spark. You may find yourself solving a problem that had no answer the day before. You may wake with a melody, a sentence, a design. In this way, the dream is a muse, not predictable, not always clear, but endlessly fertile. And the more you sleep, the more the muse returns. Creativity is not always born from effort or discipline. Sometimes it rises from stillness. Sometimes it comes in sleep. Each morning, as the light gently returns, you awaken with something fragile, a flicker of image, a feeling, a half-formed scene. Then it fades, like mist dissolving in sun. The dream slips away. This is the quiet mystery of dream recall. Why some dreams stay with us, and others vanish before we rise. Dreams, especially those from REM sleep, are not stored like waking memories. They pass through the mind, without rehearsal, without repetition, and so, without permanence. This is partly due to the prefrontal cortex, the brain's executive center, responsible for planning, logic, and memory encoding. During REM sleep, this region is less active. The brain is more creative, but less structured. As a result, Short-term memory in REM is often weak. The dream, vivid in sleep, may find no foothold in waking life. Other factors matter too. Your sleep stage at awakening, how long you've slept, how emotionally charged the dream was. People who wake during REM tend to recall dreams more vividly because the imagery is fresh, the neural patterns still humming, and some people simply recall more dreams than others. Not because they dream more, but because they notice them. If you wish to remember, you could train your mind gently. Keep a dream journal beside your bed. Record impressions, even single words, as soon as you wake. Over time, your brain begins to listen. It learns that dreams matter, and it starts leaving them out in the open just a little longer. But even if dreams fade, they leave behind traces, shifts in mood, tiny new thoughts, creative echoes. The dream may vanish, but its footprint remains. For every dream you remember, there are dozens, perhaps hundreds. You do not. They slipped through the folds of sleep, without notice, unwritten, unclaimed. But this forgetting is not a flaw. It is a function, part of the brain's careful balance between remembering and letting go. During sleep, especially in REM, the brain is highly active. Emotional centers flare. Visual processing blooms. Imagination flows freely. But memory? That is carefully limited. The hippocampus, your brain's archivist, works differently during dreaming. It stores waking memories during slow-wave sleep. But in REM, its dialogue with the neocortex is less efficient. This helps protect you from overload. If every dream were remembered, your mind would be crowded with unreal experiences, each with images, people, events. That never happened. By forgetting dreams, the brain filters, keeping only what is meaningful or unusual or deeply emotional. There may also be a biological signal. In REM, levels of serotonin and norepinephrine drop, disrupting the chemical processes that encode memory. This drop is not random. It creates space. It clears the slate for emotional processing without permanent record. So while forgetting can feel like loss, it is really curation, a pruning of dreams, a sculpting of memory. What remains is what matters, and what fades was always meant to. Each person carries a different rhythm, a different temperament, a different way of seeing the world. And so, each person sleeps a little differently. Your personality shapes how you sleep, how you dream, and how you respond to rest. People high in openness to experience, those who value imagination, curiosity, and depth, tend to report more vivid dreams and are more likely to recall them. Their minds are active even at rest. Their dreams more symbolic, sometimes surreal. Those who are emotionally sensitive or prone to anxiety may experience more frequent dreams and more intense ones. They may also have more nightmares as the mind works to process layers of emotional residue. Highly conscientious individuals who value order and discipline often maintain more regular sleep schedules, leading to higher sleep quality and smoother cycles. But there are exceptions. Sleep is not a mirror, but a mosaic. It reflects your mood, your habits, your beliefs, and your stress. Introverts may dream more inwardly. Emotions, thoughts, relationships. Extroverts may dream of scenes, crowds, adventure, dialogue. No two people dream alike, and yet each dream speaks a truth, coded, fragmented, but always real. Your personality shapes your inner night, just as your dreams, in subtle ways, shape who you are by morning. Each night, you step into worlds not made of matter, but of memory, emotion, and imagination. You dream vividly. You walk, speak, feel pain, feel joy, and yet, when you wake, you know it wasn't real. How? The answer lies in the brain's sense of reality, a delicate filtering system that usually keeps waking and dreaming apart. In wakefulness, the prefrontal cortex, the seat of reason, judgment, and reflection, is fully active. It checks facts, interprets consequences, assesses consistency. This is how you know you are not flying through glass mountains or speaking with someone long gone. But in REM sleep, the prefrontal cortex becomes less active. The brain's limbic system, especially the amygdala and hippocampus, takes the lead, prioritizing feeling over logic, symbol over sequence. The result: dreams unfold without questioning. Strange things seem natural. Impossible events pass without notice. And yet, most people still don't confuse dreams with reality upon waking. Why? Because of a brain function called reality monitoring, a cognitive process that evaluates memories based on sensory richness, emotional tone, and internal consistency. Waking memories tend to have more external detail, more sensory input, more spatial grounding. Dreams are often vivid, but lack a stable framework. And so, the brain quietly labels each memory. Waking, imagined, dreamed. It files them accordingly. This system, though usually reliable, can blur in rare moments. In lucid dreaming, you become aware inside the dream. In false awakenings, you dream you've woken up, only to awaken again. These are the borderlands. But for most, morning light separates night's illusions from the day's reality, as if the mind, with a breath, draws the curtains open. There are dreams that visit once, strange, fleeting scenes that vanish by morning. And then there are others. They return over weeks, months, sometimes years. These are recurring dreams, repeated stories, images, feelings that cycle back again and again. They may involve falling, being chased, losing something important, or standing exposed in a public place. They may not always look identical, but the theme, the emotional imprint, remains. Why does this happen? Theories vary, but most agree. Recurring dreams are often unfinished emotional business. The brain reactivates these dreams because something remains unresolved. A fear, a memory, an internal conflict that hasn't been integrated. Neuroscientifically, these dreams may emerge from the default mode network, the brain's introspective system. It revisits self-relevant themes, especially during REM. And if the brain finds the theme unsolved, it may return to it night after night. Stress can amplify recurrence, so can suppressed emotion. But recurring dreams can also be guides, not threats, but invitations. They may ask questions your waking mind avoids. They may present fears in symbolic form, so they can be faced gently. When recurring dreams fade, it is often because the message has been heard, the conflict resolved, or the situation transformed. To listen to them is not to fear them. It is to lean into what the mind is quietly asking you to see. In this way, recurring dreams are not loops. They are echoes that fade once you've learned how to answer. They're dreams that visit once, strange, fleeting scenes that vanish by morning. And then there are others. They return over weeks, months, sometimes years. These are recurring dreams, repeated stories, images, feelings that cycle back again and again. They may involve falling, being chased, losing something important, or standing exposed in a public place. They may not always look identical, but the theme, the emotional imprint, remains. Why does this happen? Theories vary, but most agree. Recurring dreams are often unfinished emotional business. The brain reactivates these dreams because something remains unresolved. A fear, a memory, an internal conflict that hasn't been integrated. Neuroscientifically, these dreams may emerge from the default mode network, the brain's introspective system. It revisits self-relevant themes, especially during REM. And if the brain finds the theme unsolved, it may return to it night after night. Stress can amplify recurrence, so can suppressed emotion. But recurring dreams can also be guides, not threats, but invitations. They may ask questions your waking mind avoids. They may present fears in symbolic form, so they can be faced gently. When recurring dreams fade, it is often because the message has been heard, the conflict resolved, or the situation transformed. To listen to them is not to fear them. It is to lean into what the mind is quietly asking you to see. In this way, recurring dreams are not loops. They are echoes that fade once you've learned how to answer. Though sleep is universal, its meaning, its shape, its rhythm can vary from place to place, from culture to culture. In some societies, dreams are dismissed as neural noise. In others, they are sacred messages from ancestors, from spirits, from the world beyond. For example, in many indigenous cultures, dreams are communal, shared in the morning, interpreted together, and treated as part of daily guidance. The dreamer is not isolated. They are supported. In contrast, industrialized societies often view dreams as private, even meaningless, reflections of stress, or fragments of the day. But science is now catching up to what many cultures have long believed, that sleep is not just rest, but a space for integration. Even sleep schedules differ globally. Some cultures observe biphasic sleep, a main sleep at night and a nap in the afternoon. This was once common across Europe and remains so in parts of the Middle East, Africa, and Latin America. Other regions, especially those with rigid work structures, enforce monophasic sleep, a single long night of rest. Modern life has disrupted many ancient sleep patterns. Artificial light, round-the-clock schedules, and cultural pressure have shortened and fragmented sleep in many parts of the world. But in quiet places, rural villages, desert communities, monasteries, you still find the rhythms of old. Early darkness, early waking, dreams treated with reverence. Culture shapes not only how we sleep, but how we think about sleep, whether it is seen as idle time or sacred time. And when sleep is honored. Dreams are honored too, as part of life's dialogue, not just its silence. Sleep is not optional. It is not a luxury, nor a habit, nor a pause between work. It is a biological necessity, as vital as breath, as fundamental as water. And when it is denied, even for a single night, the effects begin almost immediately. After 16 hours awake, attention falters, reaction times slow, decision-making becomes clouded, the brain begins to move, as if it were slightly intoxicated, not in mood, but in coordination, in clarity. After 24 hours without sleep, the prefrontal cortex, the region responsible for planning, problem-solving, and impulse control, becomes less active. Emotions become harder to regulate. The amygdala, normally kept in check, reacts more intensely. A small frustration may feel like a crisis. Physical systems also respond. Blood pressure begins to rise. Glucose metabolism becomes erratic. Immune responses weaken. Even the perception of pain increases. Discomfort becomes louder, more intrusive, and yet, sleep-deprived individuals often feel a false sense of competence. The brain adjusts, but only on the surface. Deep down, it is struggling. Studies show that micro-sleeps, tiny lapses of unconsciousness, just seconds long, can occur without warning. The eyes remain open, but the brain drifts. In high-risk environments, piloting, surgery, driving, these seconds can mean everything. Sleep deprivation does not just affect function, it distorts perception, and though the body will eventually force rest, the damage accumulates quickly. One night may leave you groggy. Several nights begin to erode the foundations. Without sleep, your memories begin to slip. Not immediately, not all at once, but gradually, as if a fog is settling over the archive of your mind. The hippocampus, which records the day's events, requires sleep, especially slow-wave sleep, to stabilize and transfer those memories to long-term storage. When sleep is short or fragmented, this process is disrupted. Memories are less precise, less detailed, less likely to endure. In students, this means impaired learning. In older adults, it may accelerate cognitive decline, but memory is only one part. Sleep loss also touches the emotional mind. The amygdala becomes hypersensitive, responding to mild stressors with exaggerated intensity. The prefrontal cortex, which normally modulates emotional response, goes quiet. The result? Mood swings, irritability, lower frustration tolerance, and in some cases, a dip into anxiety or depression. Even social perception is affected. Sleep-deprived individuals may misread facial expressions, may interpret neutral signals as threatening. Empathy declines, patience thins, and the more emotional the event, the more sleep is required to process it. Without that rest, the emotion remains raw, unintegrated. The brain tries, but it needs night to complete the loop. Occasional sleep loss can be recovered from with rest, with care, with time, but chronic sleep deprivation, sleeping less than 6 hours per night, night after night, creates a deeper, more persistent impact. It affects nearly every organ system. The heart, denied its nightly lowering of blood pressure, begins to strain. Hypertension increases. The risk of heart disease climbs. The immune system becomes sluggish. Fewer natural killer cells are produced. The very ones responsible for targeting viruses, abnormal cells, and early tumors. In fact, after 1 week of short sleep, these cells can be reduced by as much as 70%. Metabolism slows. Insulin sensitivity drops, leading to increased risk for type 2 diabetes. Appetite-regulating hormones, ghrelin and leptin, go out of balance, making the body crave energy-dense foods, while blunting the signal of fullness. Weight gain follows. Fatigue becomes normal, and inflammation quietly rises. In the blood, in the joints, in the brain, even the genome is affected. Gene expression shifts. Over 700 genes are altered by poor sleep. Many of these regulate immunity, cell repair, and stress response. And the brain? It grows foggy. Long-term sleep loss is linked to memory impairment, emotional instability, and a higher risk of neurodegenerative diseases, including Alzheimer's. Sleep is not something you can borrow forever. When it is lost again and again, the body begins to wear out, not loudly, but slowly, like stone weathered by wind. But even here, the body responds to kindness. A few nights of deep, uninterrupted rest, and some of these functions begin to heal. The damage may take time, but the path back always begins with stillness.